All right, welcome to the Unit 5 test review. Today we are going to get through this test review and talk about some important reminders to remember during the test. So starting with the first section, which is simplifying square roots, our learning target here is that you can calculate the solutions of a quadratic equation using the square root method. And in order to use the square root method with a quadratic equation, we are going to have to be able to simplify square roots. So starting with number 1 here. Number 1 says square root of -8. Well, anytime we simplify a square root, we need to find one perfect square that multiplies to this number. And we don't just want any perfect square, we want the largest possible perfect square that can multiply to this number. So the number in question for number 1 is 8, but we are going to start with writing all of our perfect squares here. Oh, 144. There we go. Okay. All right. So some of our perfect squares between 4 and 144, these are all, you get these numbers by squaring 2, squaring 3, squaring 4, and so on, all the way to 12. Okay. All right, so starting with the -8, which of these perfect squares is a factor or multiple of 8? Well, 4. So we can say, instead of saying the square root of 8, we can say the square root of 4 times the square root of 2. And that square root of 4 is going to give us 2. So our simplified answer of the square root of 8 is 2 square roots of 2. But we are not done here. The square root tells us we're going to have two solutions, a positive and a negative, and the negative tells us we are going to need an I, because as a reminder, the square root of a -1 is equal to I. So technically, we could really split up this 8 to be square root of -1 times the square root of 4 times the square root of 2. So that would leave us with 2i square root of 2. But just remember that anytime you see a square root, you get two solutions, plus or minus. Anytime you see the negative inside the square root, you need an I. So two necessities right there. All right, let's take a look at number 2. Here on number 2, we have the square root of 64. And let's check which of these perfect squares go into 64. Well, 64 is, oops, I'm erasing. 64 is a perfect square. 8 times 8 is 64. So the square root of 64 is 8, but it's also a square root, so we have two solutions, plus or minus. All right, let's take a look at number 3. The square root of 20. Which of these numbers multiplies to 20? Well, it's 4. 4 times 5 is 20. 4 times 5. We can square root both of those. So we have the square root of 4 times the square root of 5. And the square root of 4 is 2. Because we're taking the square root, we need a plus or minus. And for the last one, 72. What is the largest perfect square that goes into 72? What's half of 72? 36. So 72 can be split up into 36 times 2. So we can say plus or minus square root of 36 times the square root of 2. And the square root of 36 is 6. Now we also have this negative here, so our answer needs to have an I in it. So we say plus or minus 6i square root of 2. Now if this section or any section on this review is unfamiliar to you, you know what you can totally do? you can go online and Google some questions and practice them. Or you can go on YouTube and Google some extra assistance on how to simplify square roots. The ones with the negatives would be, you could look up like simplify square roots of complex numbers or simplify square roots with negatives or of negatives, anything like that. You'll be able to find some videos of other teachers or other people online showing you how to do that and working problems with you. All right, so next section here, it says to determine the solutions to the following equations using the square root method. And this is just a nice fancy way of saying solve for x, and you will have to take the square root. So when we solve these, we need to be very careful about what is being squared. We had a conversation about this in my class. In number 1, what is being squared is everything inside the parentheses where the 2 is on the outside attached. On number 2, I see a lot of people thinking that 9 is being squared. 9 is not being squared. The 2 is only attached to the x. So on number 2, we're going to have to remove the 64 and remove the 9 before we can take the square root. Same thing with number 3. The number 3 is not being squared. Only x is being squared. If it were in parentheses like this, then yes, the 3 and the x is being squared, but it is not. So only the x is being squared. And number 4, since we've already gone through 3 of them, what do you think is being squared here? Yeah, the x, only the x, not the 5, not the negative. All right, let's take a look at these first, starting with number 1. First, we want to isolate what is being squared, or my highlighted portion. So in order to do so, we will have to subtract 5 to the other side. Negative 20 and negative 5 is negative 25. Now that there's nothing on the left, we can go ahead and square root both sides. When we do that, the radical and the little 2 cancel out. And we are left with x minus 4 equals the square root of negative 25. Let's simplify that square root. The square root tells us we need 2 solutions, plus or minus. The negative tells us we need an I. And the 25, what is the square root of 25? 5. But we are not done here. We have one more step we need to do, because essentially here we are solving for x. And we cannot solve for x, or I guess we're not done solving for x if x is not alone. And on this left side, we still have x minus 4. So our last step will be to add 4 to the other side. Something else we talked about in my class is why can we not combine 5i and 4 to be 9i? Well, 5 has a variable, the letter I, and 4 does not have the letter I. So these two terms are not alike and cannot be combined. So the way we write our answer is x equals 4 plus or minus 5i. The 4 just goes right in front. All right? Now, let's take a look at number 2. Number 2, 9x squared minus 64. Our first step would be to add 64. Then we have 9x squared equals 64. Our next step will be to divide by 9. We have to divide that 9 before taking the square root. Going back to our original conversation here is that x is the only thing being squared. So the only thing we can square root is x. We cannot square root the 9. Okay, so we have to divide the 9 first, and 64 divided by 9 is 7. Just kidding. Let me see. 64 divided by 9 is, oh, yeah, just kidding. Oh my gosh, I don't know why I thought I could divide this. Okay, sorry, I'm getting off track. 64 divided by 9. We're not going to actually take that division because 9 does not go perfectly into 64. We get like 7.11111 repeating. So that's okay. We'll leave it as a fraction. Our next step, rewrite what we have. And we should see that our next step is to square root. Now, when we take the square root of a fraction that cannot be simplified, we'll take the square root of the top divided by the square root of the bottom. Now we have a nice, easy simplification here. The square root of 64, as we wrote up here, is 8. And the square root of 9 is 3. All right, so the square root of 64 is 8. And the square root of 9 is 3. Anytime we take the square root, we need two solutions, plus or minus. So our final answer is plus or minus 8 over 3. All right, number 3. We have 3x squared minus 25. We start by adding the 25. And then we can divide by 3. Now 150 divided by 3 is 50. And then we can take the square root, leaving us with the square root of 50, which we need to simplify. I'm just going to continue this up here on the right. So the square root of 50 can be simplified to, well, the square root tells us we need plus or minus. The 50 can be split into at least one perfect square. I know half of 50 is 25, and 25 is a perfect square. So we can say the square root of 25 times 2. Final answer is 5 square roots of 2. So x equals plus or minus 5 square roots of 2. All right, number 5, we divide both sides by -5. And 200 divided by 5 is 10, 20, 40. There we go, 40. And take the square root. And the square root of 40 needs to be simplified. So what perfect square goes into 40? Well, if you're unsure, we can take our calculator, and in the calculator, take 40 and start dividing it by these perfect squares. We want the largest number possible, so I'm going to try 16. I get a decimal, no good. 40 divided by, let's try 9, decimal, no good. 40 divided by 4, that's an obvious one, 4 and 10. So we can say plus or minus the square root of 4 times the square root of 10. So our final answer is plus or minus 2 square roots of 10. All right, determine the solutions to the following quadratic equations by factoring. All right, so I can solve quadratics by factoring. Let's take a pause before we get started and let's talk about the solution. Anytime we solve quadratic equations by factoring, by the quadratic formula, we are solving for one thing. What does x represent when we solve for x in quadratics? The x represents your solutions, aka x-intercepts, aka roots, or zeros. So when we solve quadratic equations, we are solving to find what the two x-intercepts are, or the one x-intercept, or the imaginary x-intercepts, okay? So I feel like I needed to note that, just in case. Wink, wink, wink. All right, number 1. Okay, now when we factor, we need to create a little table, and our table is going to be comprised of a times c on the top and the b value on the bottom. Now we're looking for factors of a times c that could also add up to b. So what we need to do here is label our ABC. And here we have 3, 4, and 1. So we're going to say a times c, 3 times 1 is 3. And we're looking for factors of 3 that add up to the b value of 4. So the only factors of 3 are 1 and 3, and 1 plus 3 is 4. So there we go. 1 plus 3 is 4. So what we're going to do is we're splitting the b value. Instead of saying 4x, we're going to say 1x plus 3x. Now that we have 4 terms, we can group them. And let's look at the first group, 3x squared plus 1x. What can we factor out of 3x squared and 1x? We can only take out an x. From the second group, 3x plus 1, well, we can only take out a 1. This number, the first number, is positive, so we're taking out a positive 1. Now we're ready to write our answer. X plus 1 goes in our first set of parentheses, and the second set of parentheses is what we're left with on either side when we divide what we decided to take out. So let's look at the left. We have 3x squared divided by x. That's going to leave us with 3x. Then we can say 1x divided by x, and that's just 1. Now, if we did the right side, we could say 3x divided by 1, which is 3x, and 1 divided by 1, which is 1. So it doesn't matter which side you look at. Whichever side you want to look at, left or right, it's going to get you that same factor right there. And just as a reminder, these, come on. Okay, well, we'll do a different color. These parentheses down here, these are called factors. We used factoring to find the factors of the quadratic equation. Now, are we done here? Is this our answer? No. We factored, but we haven't found the solutions or the x-intercepts. In order to do that, we're going to take each set of parentheses, each factor, and set them equal to 0. So we're going to say x plus 1 equals 0, and 3x plus 1 equals 0, and solve for x. We'll subtract the 1 from both sides. So one of our roots is x equals -1. And our other root is -1/3. And just as a reminder, if I'm moving too fast for you, then pause the video. Pause the video and try and do it yourself. All right, number 2. Number 2 says 5x squared plus 7x plus 2. So again, we label ABC. We multiply a times c, which is 5 times 2, so 10. And we're looking for factors of 10 that add up to our b value of positive 7. So our factors start with 1 and 10, 2 and 5. Those are the only numbers that multiply to 10. Do either of these pairs add up to 7? Yeah, 2 plus 5 is 7. So now, instead of saying 7x, we're going to say 2x plus 5x. Now that we have 4 terms, we can group them 2 and 2. And looking at the first group, we have 5x squared and 2x. What is the largest number we can factor out of here? 1x. And from the second group, 5x plus 2, what can we factor out of here? A 1. This number is positive, so we also take out a positive. Now we can write our answer, or I guess our factors, sorry, not our answer. X plus 1 times, now the other set of parentheses is going to be what we're left with when we divide what we decided to factor out. So let's look right here. 5x divided by 1 is 5x. 2 divided by 1 is 2. Now we can set both parentheses equal to 0 and solve. All right, so our two solutions, x-intercepts or roots, are -1 and -2 over 5. All right. Number 3. Here we have a, b, c, where a is 1. Now I'm going to teach you a little trick. When your a value is 1, the two factors that you choose from the t-chart are going to be the factors in your parentheses. So that's a cool little trick, and I'll show you. So a, b, c, a times c, 1 times -18 is -18. And we're looking for factors of -18 that add up to our b value, +3. So 18, that's going to be 1 and 18, 2 and 9, 3 and 6. Just kidding. Yeah, 3 and 6. Now, 6 and 3, if we need one of them to be negative, because they need to multiply to a negative number and also add up to +3. So if we say +6 minus 3, that'll give us a +3. So let's do our trick. -3 and 6, say x minus 3, x plus 6. Now we can see that our solutions are x equals 3 and x equals -6. Now, if you don't believe me, let's check. We can split the b value into -3x and +6x. Now, when we group them, what can we take out of the first group? We can only take out an x. From the second group, we take out a +6. There's one of our parentheses, x plus 6, that second one here. Now, when we divide, 6x divided by 6 is x, and -18 divided by 6 is -3. So there's your proof. Proof is in the pudding. Okay, let's look at number 3. And we have an a value of 1 again, so I'll show you the trick again. I'm seeing that our 8 is on the wrong side. We need it to be on the left with everything else. So x squared minus 6x minus 8 is 0. Then we look at our a, b, c, and a times c is -8. And we're looking for factors of -8 that add up to -6. So, right, so factors of 8, we have 1 and 8, 2 and 4. Now 2 plus 4 is 6, but how do we get these numbers to multiply to a -8 and add up to a -6? So if they multiply to a -8, we need one of the numbers to be negative, but if they need to add up to a -6, then we need, right, I'm remembering that this one cannot be factored. Because if we have a -2 and a -4, they will add up to -6, but -2 times -4 is a positive 8, and we need a negative 8. So this one is actually not factorable. So we're just going to go ahead and let's change the equation to say negative 8 here. That way we can add the 8 to the other side, and now we have x squared minus 6x plus 8 equals 0. Now our table will be 8 on top and negative 6 on the bottom. So our two factors of 2 and 4, they can both be negative, because a negative times a negative is a positive, but a negative plus a negative is a negative in this case. So that's good. So we can choose negative 2 and negative 4. So our two factors will be x minus 2, x minus 4, meaning our x-intercepts are 2 and 4. And if you're wondering, like, oh my gosh, Miss O, how did you do that without saying x minus 2 equals 0? Well, if you remember from our Unit 4 when we were writing quadratic equations and graphing them, we said that x lies. And x lies about who he's hanging out with. So in the parentheses, he says he's hanging out with negative 2, but really he's hanging out with positive 2. So if you remember x lies, you can easily look at the parentheses and see what our x-intercepts are without having to set up the problem. Okay, 5.4. With simplifying complex numbers, we need to remember to look at the sign. And when I say the signs, I mean the operation signs in between the parentheses. The first two, we have addition. The second two, we have subtraction. And the last two, there's no operation there. So what operation is that? Yeah, it's multiplication. So main idea here is look at the sign. Look at sign. Okay. So when we add complex numbers, all we need to do is combine like terms. So we can combine the 3 and the 5. 3 plus 5 is 8. And we can combine the 5i minus 8i, which is going to be negative 3i. And that's it. Let's look at number 2. Again, we are adding, so we can go ahead and combine like terms. 2 plus 18 is 20. Negative 6i plus 9i is 3i. All right, next ones here we have subtraction. And when we subtract, we need to first distribute the negative. It's really a negative 1. We're distributing this negative 1 to the parentheses it's attached to. Our next step will be to combine like terms. I'm just going to say CLT. Combine like terms. All right, so distributing that negative 1. Negative 1 times 18, negative 18, and negative 1 times 9 is negative 9. Now we can combine like terms. So we have 2 minus 18, which is going to give us a negative 16. Then we have negative 6i minus 9i, and 6 plus 9 is 15. All right, on number 4, we distribute the negative 1. So now we have negative 5, positive 8i, and now we can combine like terms. 3 minus 5 is negative 2, and 5 plus 8 is 13. All right, now when we multiply, we need to FOIL and then combine like terms. So starting with foiling, I had a couple of people ask me this current unit, how we know which numbers to multiply by, and I kind of thought we were past that, but that's okay. Let's talk about that. When we multiply four terms inside parentheses, we start with the first term, and we're going to distribute it to the first and the second set of parentheses, and then to the second in the second set of parentheses. Then, once that's done, we will have two numbers, one from the first multiplication and one from the second multiplication. Then we will move on to the second term in the first parentheses and distribute it to the first term in the second parentheses, giving us a number, and then we'll distribute it to the second term, giving us a number. So really we start with the first term and we give it to the second set of parentheses. Then we start with the second term and we give it to the second set of parentheses, giving us four terms. Then we can combine what we need to combine. I actually want to make a correction to my steps here. Step 2 really should be change I squared to -1. And then combine like terms. So starting with our multiplication, again, first term gets distributed here and here. So 3 times 5 is 15. 3 times -8 is -24. The 8 has an I, so it's -24i. Then we can look at the second term, 5i times 5. Well, 5 times 5 is 25, and I. And then 5i times 8i, -8i. 5 times -8 is -40. I times I is I squared. Now, our next step is to change I squared to -1. Because I squared equals -1, really, I squared is like a secret way of saying -1. So really, what's 40 times -1? Positive 40. So all we really did here was remove the I and change the sign. If it's negative, now it's positive. If it's positive, now it's negative. And now we can combine the 15 plus 40, and 15 plus 40 is 55. And then we can combine the other two, -24 plus 25. That just gives us 1i. And so we can just say I. Now for the last one, let's start with multiplying. FOIL, 2 times 18. 2 times 18 is 36. 2 times 9i. Well, 2 times 9 is 18. Times the I is I, 18i. Then we have -6i times 18. And -6 times 18 is 108. But it is a -6, so we're going to have -108i. Then we have 6i times 9i, and 6 times 9 is 54. One of the numbers is negative, that's 6, so we're going to have -54i squared. Now, changing the I squared to -1, we're going to say -1. All that does is change the sign and remove the I. So now we can combine like terms. We can combine the 36 plus 54 and the 18i minus 108i. That's going to give us a final answer of 90 minus 90i. All right, now we're going to be using the quadratic formula. It says here, based on the discriminant of the following quadratic equations, Based on the discriminant of the following quadratic equations, determine number and type of solutions. So the discriminant can tell us how many solutions we'll have and what type of solutions, whether they're real or imaginary. And just to say it again, when we say solutions, what are we talking about? We're talking about the x-intercepts, the roots, the zeros. So let's make a little note here before we get started on this. Our first note is that when b squared minus 4ac, the discriminant, when the discriminant is positive, we have two real solutions, which means that our parabola will cross the x-axis at 2 points. When our discriminant is equal to 0, we have one real solution, which means our vertex of the parabola is on the x-axis. And when our discriminant is a negative number, then we have two imaginary solutions, which means that our parabola will not cross the x-axis. All right. Now, I'm not writing this just for me. I'm writing this for you because this is important and you will have a test question on this. All right, so starting with number 1 here, we have 2x squared plus 6x plus 5. So we need to label our ABC. And something we should also talk about is that your ABC does not include the variable. It doesn't include x. Here's our standard form right here. Notice how A is attached to x, B is attached to x, and C does not have a variable. So when we say ABC, we're talking about the coefficient, not the x's. So those are two separate entities. All right, so ABC, discriminant, we use the discriminant, b squared minus 4ac. So here we have 6 squared minus 4 times a times c, so 2 and 5. 6 squared is, 6 squared is 36. 4 times 2 is 8. And 8 times 5 is 40. So 36 minus 40 is going to give us a negative 4. And the negative tells us, we just wrote it up here, if your discriminant is negative, you have two imaginary solutions, which means it does not cross the x-axis. So which one of these answers says that? Has two real solutions? No. The function has two complex imaginary solutions? Yes. One repeated real solution? No. The function has one real and one complex solution? No. All right, let's look at the second one. We label our A, B, C. A is 1, not 1x squared. A is 1, B is 5, and C is 2. So B squared, 5 squared, minus 4AC. So 5 times 5 is 25. 4 times 1 is 4. 4 times negative 2, or negative 4 times negative 2 is positive 8. So 25 plus 8 is going to give us 5, 6, 7, 8, 9, 10, 11, 12. 32. Now that is a positive number, so we have positive discriminant, which means 2 real solutions. Which one of these answers says that? A. All right, moving on to the last 2 problems. It says, determine the solutions to the following using the quadratic formula. So, of course, we're going to calculate that discriminant first, and then plug it back into the formula. So, first things first, we need our equation in standard form. 1 and 2 are not in standard form. We would need to add 5 to the left to get it in standard form. Now we can go into labeling our A, B, and C. A, B, C. So the discriminant, right. Our discriminant is B squared minus 4AC. So B is 6, A is 8, and C is 5. 6 times 6 is 36. 4 times 8, 16, 32. And 32 times 5, well, 2 times 5 is 10. 3 times 5 is 15, so 16. So we're going to have 36 minus 160, which is going to give us 124. Negative 124. Because it's negative, how many solutions do we have and what kind? 2 imaginary solutions. So how many times does it cross the x-axis if it's imaginary? It does not cross the x-axis if it's imaginary. Okay? Does not cross the x-axis. All right, now that we have our discriminant, we can plug that back into the quadratic formula. So we're going to say x equals negative b. Our b here is 6, plus or minus the square root of negative 124 all over 2a. Okay. So now getting into it, we have negative 6. And we need to simplify the square root of 124. So negative 124. I probably should have just pulled this down. Let me move this here. Sorry you can't do this on your paper, but oops, do it. There we go. That's better. Okay, so simplifying the square root of 124. What does that look like? Well, if we have the square root of negative 124, the square root tells us we need plus or minus. The negative tells us we need an I. Now, 124. What perfect square goes into 124? I'll tell you, it's 4. So square root of 4 times square root of 31, because 4 times 31 is 124. So the square root of 4 is 2. So our simplified square root here is plus or minus 2i square root of 31. Now, so we are not actually done here. We have one step further. We need to simplify. So looking at our whole numbers, in order to simplify a fraction, you need, or at least a complex fraction, you need all 3 whole numbers to be divisible by the same number. In this case, they are all even numbers, so we can divide them each by 2. Negative 6 divided by 2 is negative 3. 2 divided by 2 is 1. And 16 divided by 2 is 8. So our final answer for number 1 is x equals negative 3 plus or minus I square root of 31 over 8. Woo! I love these. Okay, let's get number 2 done and be done with this. So number 2, I'm just going to make this a little smaller for me. And we'll split it nicely. All right, number 2, starting with our equation, we need to label A, B, and C. A, B, C. Oops, it's not in standard form. I made a mistake. it's not in standard form. We need that 20 to be added to the other side. So now we have x squared minus 9x plus 20 equals 0. Now we can label a, b, c and start with our discriminant. Our discriminant, what color did I use? Purple? We'll use red. B squared minus 4ac, where b is negative 9, a is 1, and c is 20. So 9 times 9 is 81, and 4 times 1 is 4. 4 times 20 is 80. So we have 81 minus 80, which gives us 1. That's a positive number, so we have two real solutions. So how many times will this cross the x-axis? Twice. The two real solutions will cross the x-axis 2 times. All right, now taking that 1, let's plug it into our quadratic equation. X equals negative b. Our b in this case is negative 9. Plus or minus the square root of our discriminant 1 all over 2a. Now simplifying this, what is the square root of 1? Well, 1 squared is just 1, so the square root of 1 is 1. 1 times 1 is 1. All right, so simplifying, we have positive 9 plus or minus 1 all over 2. Now, this might be a comfortable spot to stop because it looks nice and it looks like we might be done, but there is no I here. There is no square root here. These are all regular numbers, so we can go ahead and combine them. But notice how we have a positive 1 and we have a negative 1. So we're going to do our positive and negative solution, where we have x equals 9 plus 1 over 2 and x equals 9 minus 1 over 2. 9 plus 1 is 10. 10 over 2 is 5. 9 minus 1 is 8. Over 2 is 4. So our two solutions for number 2 are 5 and 4. This concludes our review video, so please get the review done. The best way to study for this test and any other test really is to work the review as much as you can on your own and then go and check yourself with the video. So if you've already watched the video, maybe you come pick up a second review from me and try it on your own and then check your answers and see how you did. If you cannot do this review on your own, or maybe you can't do any of it on your own, I can probably say that you're not going to do very well on the test. You have to be able to know this stuff to be able to do well on the test. That's just how it works. Okay, well, I'll stop haggling you. Have a great day and good luck on your test.